Okay, let's get started. Do you have any question for me?
Yeah, I'll send you on WhatsApp.
Oh, okay. Is it from your schoolwork?
No, it's from the 10-year series.
I have not received yet.
Oh yeah, I'm sending. Okay. You received it? Yeah, I can hear you. Yeah, I got a part A answer, but I don't know how to do part B. Yeah, I can hear you. I sub in the value, then I form a simultaneous equation. Oh, yeah. Use calculator. Okay. Yeah, I can see. By using calculator. -5. -4.
So use your calculator. So what do you expect? Do you expect to have how many answers do you expect you can get from your calculator?
2 answer. 3 answer.
Okay, right? supposedly you are supposed to get 3 lah, huh? So over here the question says expressing non-integer roots in the form. So basically you should expect some value of x to be indefinite. Indefinite means you should be getting like 5.5, 2, 3, 4, 5. You know, this is called indefinite number. Okay, so you are expecting this kind of number, but instead of expressing that answer in this format, they want you to express it in this format. Exact. Okay, this one is not exact, right? And this one is exact. So how are you going to do it?
Y times 2 the answer.
I will say first you need to. So first you already have the x plus 2 as is a factor, right? So you should long division it first. Okay, you should long division it first. So after you long division, what do you get? So basically, we talked about long division last time. So let's say
you get a remainder.
not only you get a remainder, so you put in x plus 2, which is a factor, right? Am I right? Which is a factor. So not only get a remainder. Wait, when it's a factor, you shouldn't get any remainder. Okay, so this is called the divisor. Okay, so you should get a quotient, right? And then of course, when this is a factor, right? Okay, when this is a factor, your remainder should be 0. If x plus 2 is a factor. Okay? Okay?
Okay.
The question says this is a factor, right? So that's why your remainder should be 0. Okay? So can you tell me what's the quotient after long division? So it means what's the quotient after you do the long division? Yeah. Have you done this step?
No, I haven't.
So that's the one you need to do. So basically you will get a quotient. So you get a quotient. So what do you think? The quotient will be a what equation will your quotient be? It will be a quadratic equation that looks like this. Am I right?
Okay. Yeah.
Yeah. So if you have a quadratic equation, so you can use this. And then this will give you the answer which is required by the.
Okay.
So now you understand how to do the question already?
Yeah, but if it's 2a, that means the a have to be 1, right?
No, you need to find out what's the quotient first. So what's the quotient? So you will.
Let me work out now.
Yep. So please work out the quotient. So basically, okay, the technique is once you get the quotient, so let's say if you get 2x, let's say this will be 2x, and then if this is your 1, and then this is your 2, right? All you need to do is you need to sub in all this value into your this. Then you will get the answer in that format given by the question. So this is the technique. Okay? Can? So far so good. So 4 marks easily you can get. Okay? Just this question, or you have more questions?
I remember we still have 2 questions from last
Oh,
lesson.
equidistant.
Yeah.
Let me go to the assignment. I'm not sharing yet because I'm going to the. Let me share my screen now. I'm going to the Google Forms. How come I'm here? Okay, so let's take a look at 20. So let me get it out. Okay, 20 says find by construction the point P that is equidistant from the point ABC. Okay, then hence draw a circle passing through A, B, and C. Measure the radius of the circle. Okay, so first thing first, can I ask you? So before you can do this question, right? So over here it says by construction. So what it means that you are supposed to use a compass, okay? And then you are also supposed to use a protractor. Okay? 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 So the compass is for you to do what? For you to measure angles. Okay? Then the projector is for you to draw circles and for you to draw lines. Okay? So and of course you also need the this these rulers, the triangular rulers. Do you have them?
No.
Okay. So basically the tools you need, right? The tools you need is all this. Okay. So what do you have? What do you have?
I got a projector and only the ruler.
You have a projector and then ruler.
Yeah.
These two?
Yeah.
Okay, it's okay. So let's in fact you need a compass as well. Okay, but anyway, let's do with these two first. Okay, so first you have this A B C. Okay, so let me make the A B C bigger. I mean, let's make this triangle bigger. Actually, I can do for any triangle actually. So let's just do for this triangle. A, B, and C. Okay, so I need a point P, my point P, such that, so just roughly, if I were to find a point P, so let's say if this is point P, right? So it should be equidistant. It should be equidistant to A, B, and C. What it means is, if I were to draw a line from my A to P, so first thing first, you need to understand what's the meaning. So if I were to draw a line from A to P, and then B to P, and then C to P, so what it means is all these lines are
Equal.
equal. Yes. So that will be the location of your point P. So how do you find this point P? Okay. So how do you find this point P? Okay. So there are many ways to do this question, but let's try one. You cannot estimate. Okay. Okay. So what you need to do is, let's talk about how to draw just two normal. Let's talk about the concept of, let's talk about these two concepts first. Number one, perpendicular bisector. Okay, and then the other concept is angle bisector. Okay, so let's start with the first one. What's the meaning of perpendicular bisector? Okay, so what's the meaning of perpendicular?
90 degrees.
Yep, it should be 90 degree, right? Okay, it should be 90 degree. Okay, and then what's the meaning of bisector in English? Okay,
I don't know.
so basically it's like it cuts something into half. Okay? Basically you half something. Okay, so now if you are given this line, okay, let's call this line A and B. Okay, let's call this line A and B. How do you draw the perpendicular bisector of A and B? Or rather, how do you draw the perpendicular bisector of this line AB? Okay, so imagine you are having this. Imagine you are using this projector now. Okay, imagine you have a projector. This is the needle, okay, and this is the pencil of your projector. So what you do first is you put your needle here. You put the needle here, okay, and then you are going to draw a. You are going to use the pencil. You are going to draw a arc. Okay, you are going to draw an arc. Okay, so the arc will be like this. Okay, so this is where your needle should be placed. So the other leg, right? The other leg of the, so basically what you need to imagine is another leg is your pencils. Okay, this is your another leg of the pencil. And this pencil, right? You can draw an arc here, and then you can also draw an arc here by this pencil. Okay? Can you imagine?
Can imagine.
Can you?
Yeah.
Then next, instead of putting the needle at point A, now you put the needle at point B. So now you put the needle at point B. And then the other leg of the projector, you are going to draw another arc. Okay? Can you imagine? So this is the pencil. So basically you draw another arc. Okay? So then you will end up with what? You will end up with 2 points. So you will end up with 2 points. One of them is here. One of them is here. And what you need to do is you just need to connect these 2 points. And pardon?
Can I ask that? The distance from A. Like, how do you know how far you should draw?
Hold on first. I'm going to explain this perpendicular bisector. What is the end product and what this end product perpendicular bisector? How far is it away from A and how far is it away from B, or the angle? Okay, or what is the property? What is the property of this perpendicular bisector? And I think I'm going to answer your question. Okay, I think I'm going to answer your question. Okay, so listen first. So first, once you connect these two lines already, so basically you end up with this line. So this line is a perpendicular bisector of AB. Okay, so what it means here is this is a 90 degree. And if you are going to like go from your A to this point, any point, let's say, let's pick one point on this line. So which point you want to take on this line? So now I can erase this 2 point because what I have already drawn the perpendicular bisector. So let's pick any point on this line. So this is my perpendicular bisector. So I call it PB first. Okay. So let's pick any point on this PB. So let's pick this point. Okay, this is the point on PB. So this point, right? If you were to draw a line from A to this point, and if you were to draw a line from B to this point, and what do you think? What do you think?
The distance is the same.
This one and this one is the same. So that means if you were to look at this, let's say this point is your point C. So this will be a isosceles
Triangle.
triangle. Yes. Okay. So let's pick another point. Let's put another point on the line again. Let's not pick C. Let's pick another point below. Let's call this point D. And if you are to connect B to D, and then if you were to connect A to D, you will end up with an isosceles triangle as well. So your this AD is equal to your BD. So that means if you draw your perpendicular bisector of AB, any points on this line, if you were to join A to this, from A to this line or B to this line, right? You will form an isosceles triangle. Okay? So I think I have answered your question just now. Okay? So the answer will be any point on the line will be equidistant to A and B. Am I right?
Yeah.
Yeah. So remember, any point on this line PB, your perpendicular bisector, will be equidistant to your A and B. Okay, so that is the property of a perpendicular bisector of a line. Okay, so now let's talk about angle bisector. So let me form an angle first. Okay, so let's say this is your angle. Okay, sorry. Okay, so now you have this angle. So let's call it ABC. Okay, so angle, basically it refers to just an angle. Bisector, half it. Okay, so basically what it means is half it or cut into half. So basically, if you have this angle ABC, so you need to cut this angle ABC into halves. So how do you get this angle bisector? So once again, use a protractor. So imagine your needle is here, right? And then use your pencil. Use your pencil. You to draw an arc here and here. Okay. So once you have these 2 points already, and then move your this needle here. So your needle will be here now, and then your this, then you can get another arc. Okay, and then now Move your needle to this point. Okay, so I'm going to erase this. Move your needle to this point, and then your pencil, you draw another arc from here. You should get here. So therefore, you will get your this point. So once you get this point, what you need to do is you just link your B to this point, and then you will get an angle bisector. Okay, so this will be your angle bisector. I call it AB.
Can I ask, how do you know that from B, like how far you should draw? Cause like the thing.
No, it's okay. Now I'm not concerned about how far. Now my concern is I just need to cut the angle into half. That's my concern. I'm not talking about distance at the moment. I'm not talking about distance at the moment. I'm talking about angle. Angle is like the let's say it's 50 degree. I'm more concerned about the size of the angle, not so much about the length of the distance. Okay, not so much about this length. Okay, so basically you can extend. I mean you can extend it, but anyway, I mean as long as it cut through this point. So first it must start from B. It must start from B, and then it must cut through this point. So whether how long this even how long this it is, it doesn't matter at the moment, because now I want to find the angle bisector. So basically this angle and this angle, right, should be the same. If I call this angle 1, I call this angle 2. So angle 1 is equal to angle 2. Okay. So I'm more concerned about dividing the angles into two halves. Okay. I'm not concerned about distance here, because that's why this is called the angle bisector. That's why it's called the angle bisector. Nothing to do with length here. Nothing to do with distance. Okay. Can? Okay. So now let's apply these two concepts. Okay. Let's apply these two concepts with a triangle. Okay. Let's not talk about your that question first. Let's just do some simple question based on what we have learned just now. Perpendicular bisector and angle bisector. Okay, so let me find the angle bisector of my ACB. So basically, I want to cut ACB into two halves. Can you see it? I want to cut it into two halves. Okay, so what I need to do is I need to have my compass. I need to like make one arc here. I mean projector, make an arc here. Then continue. This will be my needle point, and then I need to make another arc, and then similarly another point. I make another arc. So once I get this point already, then I just need to draw a line. So this will be my angle bisector of my ACB. So over here, it doesn't look very accurate because you know, right? I'm not using I mean, I'm just demonstrating the technique, not so much about the accuracy here. Okay. So this is called angle bisector. Are you there?
Yeah.
Okay.
Okay.
Okay. So just, I mean, let's not talk about the accuracy first. So now I'm going to erase it. So once I get the angle bisector already, so let me just make it little bit more accurate. So later I can make things more perfect. Okay. So let's assume that this is your angle bisector. Okay. Now let's find the perpendicular bisector of BC. So that means it's basically same thing. You just draw an arc with your needle at point C. Now you draw another arc with your needle at point B. So you have another arc. So you just join these two up. You will get the perpendicular bisector of BC. So it should be somewhere here. So yeah. So This will be your angle bisector. Okay, so this is your perpendicular bisector. Okay, now my question is, if you have, then you see this intersection point between your AB and your PB, right? Right?
Yeah.
So what is, so basically that's how you should draw your AB and PB. Okay? That's how you draw your AB and PB. Now, let me get rid of the AB first. Let me get rid of the AB first. Now, let me draw the perpendicular bisector of AB as well. So that means it should be, so this will be my first point. So I make an arc. So this will be my second point, make an arc. So basically you will get another. So over here, just let me estimate first. Okay. But you are supposed to use the tools. So I will get my perpendicular bisector somewhere here. Okay. So let's say this is the PB of my AB. So let me draw another one for AC. So you will get another one somewhere here. So this is your PB for your AC. Okay, so do you see that you have this point where they align with each other
Yeah.
or intersect? Okay, so this point, right? This point here, what do you think? Isn't it equidistant to C, A, and B? Isn't it?
Mm.
So I think I have answered your question, which is part our assignment. This question, yeah. So by construction, the point P, so that will be our P lah, equidistant from point A, B, C. So this will be our point P. So this point, intersection by all the perpendicular bisector for each line, that will give us our point P. Okay?
Okay.
So next, let's answer the second part of the question. So hence, draw a circle passing through A, B, C, measure the radius of the circle. So that means now you need to draw a circle. So it means this circle, right? This circle must go through these 3 points. Okay. Okay. So can I ask you? So in order for the circle to pass through this A, B, C, right? Okay. You know what it means or not? It means, right, your P here will be your center of the circle. The reason is, what's the reason? Because your all the lines here, right, equidistant, right? So what it says is, this one is the radius. This one is also a radius. This one is also a radius. So what it means is, so basically you use your protractor, the needle it should be on point P. Okay, that means basically this will be your pencil, and then this length, right, should be your radius, and then you just park it here, then start to draw, you know, something like that. Do you get what I mean?
I know.
Okay, so then you will get your circle. So I have answered second part of the question, and you are asked to draw and measure. So basically, I have drawn and measure the radius of the circle, which is this part. Okay. Okay. So now let's look at the second question. Part over here. So it says find. We have another construction question here. Okay. This one. Okay. Just now. Okay. I want to give you a summary. So what we have done here so far is we are making use of the perpendicular bisector. Okay. Did we use angle bisector? No, right?
No.
No, not yet, right? So the next question, which is this question, we are going to use that. We are going to use that. So I want to show you how you can make use of perpendicular bisector, which is here, and how we can use angle bisector later on for the second question. So now I'm going to go through that together with you for this question. Okay, so over here it says the point point Q, that is equidistant from the line XY, which is here, YZ, which is here, and then XZ. So what they want is they want a point here. Let's assume this is Q, such that is equidistant to line XY, YZ, and XZ. So what it means is, how do you draw is this? Okay, so let's say this line to here, and then this line to here, and then this line to here. By the way, this point is not equidistant, very clear to us, because clearly these three lines are not the same. So it's not equidistant. So that means the point should be somewhere lower. Okay. Okay.
So can I stop the lesson for a while? Because my family member, they are talking very loud. Can I ask them to be a bit quiet?
Which one?
Just give me 1 minute.
Okay, sure.
Thank you. Okay, Daniel.
What happened? I didn't catch what did you say?
Oh, because my family member, they were talking quite loud. Then I asked them to be a bit quiet.
Okay, understand. So let's come back to this. So basically, we are going to find a point such that these 3 points, right? I mean this point, such that this point Q, such that these 3 lines are the same. By the way, when I talk about these 3 lines, right, you cannot anyhow draw these 3 lines. Why? Because this line must be perpendicular to this YZ, okay? And then this line must be perpendicular to your XZ, and then this line must be perpendicular to this XY as well. So once you can get these 3 lines and they are perpendicular to each side, if these 3 lines are the same, then this is your point Q. Okay, so the important thing is they must be perpendicular to each side. Okay, then you consider the point as equidistant. to each side of the triangle. Okay?
So
Okay?
for the previous one also the same.
Pardon?
For the previous one also the same.
The previous one, I did not consider the perpendicular to the side. Okay? The previous one, okay, if I were to draw the previous one, right? The previous one, I did not care. The previous one, basically, I just like move it like this, you know. I did not care about whether it's like 90 degree to my side. Can you see?
But do we have to care if it's
We
90
need,
degrees?
it must be perpendicular to each side. So perpendicular to this side, perpendicular to this side, and perpendicular to this side. Then only you measure this three distance. They must be the same. So it must be perpendicular to each side. So that is the first condition. It must be met.
So we just find any point on the line.
No, there is only one point. There is only one point. There is only one point here that will meet the requirement, such that your this, let's say I call this line 1, I call this line 2, and this line 3. So there is only one point, and that gives you line 1 is perpendicular to YZ. Line 2 is perpendicular to XZ. XZ. And then you have your line 3 is perpendicular to your XY. And then this condition must be met. Then if your L1 is equal to your L2 and your is also equal to your L3, then your point Q is the point. Okay.
Okay.
So this is the first condition you must meet. Okay. And if you meet this condition already, and then the second condition, L1 is equal to L2 and L3, then point Q is the point. Okay. If you don't meet these two requirements, then the point is not the point. Okay. Okay. So now let's use angle bisector to find this point Q. Okay. So let's find this point. So to find this point, right? First thing first, I must find the angle bisector. Angle bisector. So I call it AB. Yeah? Short form. I must find the AB for my this angle first. Okay. So to find the angle, I just need to do this. Find an arc, and then use this point as another starting point. So I get one arc here, and then use this as another point as a starting point. I get another arc, and then there is this intersection point. I just need to connect. So this will be my angle bisector for ZYX or XYZ. It's a bit off, so I just try to like make it more accurate. So later you will see something. So let's assume that this is our angle bisector. Okay, let me make it more accurate so later you can see something. Okay, so this is your angle bisector. So this is your AB. AB for this angle. So do the similar thing for your XY. Do similar for XZY. So in this we are here. Okay, so you should get something looks like this. Okay. Of course, it's not like, oh, you just draw the line then estimate. No, use the technique we show here. I'm doing it here like freehand because I don't have a projector with you. Okay, it's hard to show it to you. Okay, so please do it this way. Here. Okay. Get good.
Okay.
Get another. Now we should be doing for this angle. So let's draw another line. Can you see an intersection point? So this intersection point, right, of all these AB, right? So you just label your this angle bisector like this, okay? And then this will be your point Q. So the intersection of all angle bisectors, okay, will be the point Q, and this point Q will be equidistant. So 90 degree, 90 degree, and then over here you can see it's not very accurate. The reason is I'm using freehand. That's the reason why. But if you really follow closely to find the angle bisector of each angle, right, you will end up with a point that, so this point will give you an equidistance to all the sides. Okay? And, okay? So now it says hence or otherwise draw a circle that is tangent to the line xy, yz, and xe. Measure the radius of the circle. Draw a circle that is tangent to the line. So basically what you need to do is so basically you have this, you need to draw a circle inside this one such that it's tangent. Tangent means what? Tangent means you draw the circle like this, okay? This one is the tangent to this, so this is tangent to the circle. You know what's the meaning of tangent to the circle?
No.
Tangent to the circle is, okay, so that means I have already taught you how to figure this part. Now we should be talking about the second part, hence or otherwise. Okay, so let's focus on the second part. So first part, you're okay here?
Yeah.
Okay, so now focus on the second part. I'm going to take this out and go to the next slide. So let's focus on the second part. The meaning of tangent to the circle.
Okay.
Okay, what is the meaning of tangent to something? What's your understanding?
Is it
So let's say
that you touch?
it touch, right? It touch at one point, right? So let's say if I need to find the tangent, let's say I want to find the tangent at this point. What you do, you just draw a tangent, which is a straight line, something like this, right? That cuts across this point, right?
Yeah.
So it should cut the curve at one point, not many points, just one point. So as long as it cuts the curve at this point, just this one point, and that's called a tangent, right? That's the meaning of it, right? Okay, so with this understanding, so now the curve is not, so now the curve is not a curve, it's a circle. So let's say I have a circle. Okay, and this circle, right? If I were to put this circle inside this thing, inside this XYZ, so I may use another slide. So let me grab this entire question over. So right now, you want to draw a circle inside this thing. So basically, let me get this circle over. You want to draw a circle inside this thing, inside, it must be inside, such that is tangent. I mean your this. Yeah, hold on. I just assume first. Assume first. Okay, so is this a tangent? Is your xy tangent to the circle here? Is it?
Yes.
Yes. So over here, is this the tangent? Is this xz tangent to the circle?
Yeah.
So is this this yz tangent to the circle also? Am I right? So what you need to do is you need to find this circle. So what is so special about this circle? So such that it will be tangent to this. No, I mean this yz will be tangent, xz will be the tangent, and yx will be the tangent. So the key is, if you want this to happen, right, your basically this will be 90 degree, and then this will be your 90 degree, and this will be 90 degree. So basically what we have done just now, here, right, what you need to do is you just need to take Q as the center of the circle. You just need to take Q as the center of the circle. Then, because Q is already 90 degree to this YZ, and then it's also 90 degree to your YX, and it's also 90 degree to your XZ. So what you need to do is you just need to take this as the center of the circle, and then the radius will be, since this line, this line, all these three lines, they are the same, right? L1, L2, L3. So L1 is equal to L2 equals to L3 from part 1. So what you need to do is, this is the radius, you just draw a circle. So then that is the circle you draw for part 2. Understand?
Yeah.
Okay?
Okay.
Okay. I think this part 2, right? I think is even so-called more difficult than the question you asked me during that lesson. Okay. So with this question, okay, both part A and part B, I think I have explained more to you than the question you asked me during our last lesson. Okay, so you get more knowledge out of this question than you just showed me last time. Okay.
Can I ask? Is this is EMAC, right?
This is EMAP, under EMAP, yes.
Is this tested? Because I haven't made it.
Why not? Why not? If we are talking about O level, definitely you will be tested. Okay. But if you are asking me about whether it will be tested in your upcoming test, I think it will be. Why? Because I remember the question you asked me last time, it doesn't have this part. Okay. It doesn't have this part. Okay. It doesn't have this part. But isn't it something good for you? You learn more than your peers. Isn't it better for you?
Yeah.
Yeah. So if the question comes out like this, you should get the points. If the question asks you even more, your peers might not know, but you will know. Isn't it an advantage to you? Right?
Yes.
So I'm teaching you more than required, so which is good for you. Okay?
Okay.
Okay? Okay?
Okay.
So
Oh,
any more
I
questions?
think, yeah, it's for the same assignment. Can you go back to the assignment? I got one question only.
My assignment?
Yeah.
Here?
Yeah, I forgot to ask last lesson.
Yeah, like
Question, can you go to question 7B?
here, right?
Yeah, this you already explained it to me, like how I should do, but I get the answer, but I'm not sure if it's correct.
Oh, I talk about this question, like I say, right? I'm not very concerned about the answer. Because I think I remember I said this question, right, is a question, the question I designed myself. Okay, I didn't care about whether the answers make sense or not, but I focus more on the method. Okay, I think I acknowledge your answer for M is correct last time. And then what I say is,
Yeah.
once you get your M, right? Once you get your M, so let's assume, what's your M, by the way?
I forgot already.
Never mind, let's assume your M is 2. Okay, assume your M is 2. So what you need to do is, basically you have two equations, right?
I remember already. I think it's -2 or 10.
Okay, good. So let's say -2 first. Let's start with -2 first. Okay. So -2, you have one pair of equation. Am I right?
Yeah.
Then when you have 10, right? You have another pair of equation. Basically, you have two pairs of simultaneous equation. Then you just solve these two pairs of equation. Okay. So basically, this for this you will get your x and y. Okay. I don't know how many. Probably you have like 2x. That's why you have 2y. Okay. From here, and then probably here you also get 2x or 2y. Okay. I'm not too concerned about the answer actually. I'm more concerned about the method. So this is the method. Okay.
Oh,
Okay.
then
And
how do I find the intersection point if I got so many x and y?
so find the intersection point. So basically, let's say you have this x equals to 1, then y equals to 2, then you -1. Let's assume. Let's assume. So basically, you have how many intersection points? 4 lah. Why?
Oh,
1 and 2. This is 1. This is one intersection point, right? So this is second one. When do you have 4 intersection points? Can I ask? When? So basically, you have 4 intersection points. How do you get 4 intersection points? Can you think of? How do you get 4?
It's um, um, bigger than two roots, two real roots.
So let's say you have something like this. Okay. So what you have is, let's assume. We have to assume something. So here you will get what? How many intersection points you have? 1, 2, 3. And then you get 3 intersection points already. Okay. So you get 3 intersection points already by doing this. Okay. Then to have 4, right? How do you have 4? Let's extend. Like I say, for this question, right? The more important part is how to solve. You get 4.
Okay.
Like I say, for this question, right? This question alone, the important part is the techniques or the method to solve. Okay, not so much about the answer you get. Okay.
Okay.
Okay. Okay.
Okay.
Yeah. So okay, what did you learn in your last week?
School.
Yeah, school.
Um, it's already holiday, so our teacher never teach anything new.
But the question you asked me, right? You just have only one question to ask me. So how many questions you have done, by the way?
I have done some course.
Ah.
I actually had a book, and on it, right, there's like practices, and then followed by a booklet that gives a working and answer. So it's like if I don't know this question, then I can go and check on the workings, then I'll understand. If I really don't understand, then I'll ask you. So like there's not a lot of questions that I don't understand.
Okay, so that means I hear from you. Most of the question you just refer to the answers and you manage to understand them.
Yeah.
Okay, that's a good sign. But have you purchased your e-math 10-year series?
Yeah, I already bought it.
Okay, so have you done any e-math questions?
No, so far I haven't touched email yet.
Okay, so I think you should touch e-maths.
Okay.
I think you should touch e-maths. You have spent enough time. I think you have spent enough time on A-maths, or rather, you have spent more than enough time on A-maths. I think you need to put back your focus on your E-maths. Okay.
Okay.
And so for the EMAF chapter, right? Okay. For the EMAF chapter, I want to give you because I remember the last lesson I show you what we have learned for AMAFs chapter by chapter. Okay. So let me give you
Yeah.
a summary of the chapters you are going to learn in EMAF. So I just want you to know what you have learned so far for EMAFs and what are the chapters that you can do. So EMAFs. Okay, so here it is. Okay, so first thing first, trigonometry, which is Tokaso and sine rule, cosine rule. Can you see it?
Yeah.
Which you can do. Okay, hold on. How do I? Okay, good. So let me just okay. So let me just write down the chapters that you can start doing for EMAth. So for EMAths, trigo, and then measurements. So measurements are shapes. So measurements are shapes. Shapes meaning like how do you find the and this the cone, the cylinder, and all those things, you know. Okay, measurements. Okay, and property circle. Have you thought about properties of circle?
No.
Oh,
Not,
not yet. Okay,
not yet.
not yet. Okay, so okay, let's look. Vectors, no. Okay, measurement you can do. Trigonometry you can do, and then congruence and similarity.
Hmm?
Similar triangles.
Oh, what's that?
Similar triangle. This one. So let's say I have a triangle and then I have a bigger triangle and then this one is similar to this. Have you learned this?
No, but then I think there was one question. It was my holiday homework, and it was exactly like that. Then I used algebra to solve it.
Then it's okay. So that means that means you can also try already, but that means what I want you to try because since your holiday homework has this chapter, right? That means you'll be tested. So that means you should also do congruence and similarity. Okay. So when you don't understand those questions, then you can ask me the next lesson. Okay. I see some more. The algebraic manipulation, which is the indices part.
Mm.
Algebraic, basically algebra lah. So that means like you have 2x to you have this, and then how do you simplify? How do you simplify this? You still remember? Okay. And then
Yeah, but very.
of course, functions and graph. Functions and graph is I think you have already practiced it like over here. Yeah, this one coordinate geometry, gradient of line AC. Okay, this is under functions and algebra. Okay, let me scroll down.
What about quadratic equation?
Equation
Yeah.
and equality, definitely. AMAth, we have covered also. EMAth, definitely you need to do. And then of course, these are number ratio rate, right? All these right? Ratio. So this one is a very general one. You can also start already. Okay. Ratio means like the number of stickers I have to the number of sticker you have is 2 to 3. And then blah blah blah, that kind of thing. So
Okay.
we have a total of 70 stickers. So how many stickers you have? That kind of question.
Isn't it a primary school question?
Of course, the question I gave you just now is a primary 6 question. But when it comes to Sec 4, right, of course, they make it more complicated. So like they say, now you give me 20 and then what is the ratio at the end, that kind of thing. And then you receive another 20 and then what is the final ratio? Okay?
Okay.
Okay, can. So basically, if you look at my this there is this playlist, right, under secondary 4 e-maths, right? So if you look at it, you can actually follow which chapter you have learned, and then you can do accordingly in your 10-year series. Okay, please go ahead and do those questions. And of course, I expect a lot more questions you are going to ask me in our next lesson. Okay?
Okay.
Yeah, because I feel that this time round you didn't ask me enough questions. Okay, that's not what I want. I want you to ask me a lot more questions. That means what I'm trying to say is, of course, I expect you to know how to do the questions, but I expect you to know how to do those questions. Plus, you practice even more questions that you don't understand. Okay,
Okay.
you need to work harder. Okay.
Okay.
Okay. Any other question?
No, so far no.
Okay. So our
Okay,
next,
wait.
yeah,
Actually, I have class for binomial.
binomial, yes.
So far, what I have learned is it like everything? Cause I feel that
What is everything?
I
I didn't catch. Sorry.
like for binomial so far I have learned is it like almost everything or have we like covered almost the whole chapter?
For binomial, we have covered already. For binomial, we have covered already. Okay, but for
So
binomial,
that's
cover all.
uh
Yeah,
oh
you
okay.
you can also what? You can also look at your school materials. You look at your school materials, and then you will see whether we have covered all or not yet. What I'm trying to say is, if you look at your school materials, if your school materials have questions that you don't understand, that means you can ask me. Okay. If you look at your school materials and you understand them all, then that means we have covered them all.
Okay.
Okay. Okay. Or another thing you can check whether we have covered all for binomial is uh, I have a playlist for Sec 4 A math as well actually. Okay. Not this one. So under binomial theorem, yeah, 20 minutes, probably there are like 3 or 4 questions inside. You just need to watch them one more time, and then that should be all the materials from binomial expansion. Here, binomial theorem.
Okay.
Okay? Okay? Okay?
Mm.
Okay, so any other question?
No.
So if you are wondering, whether we have covered certain chapters fully, so I think the first thing you can check is over here I have all the videos um, grouped by chapters already. Okay, so what you need to do is you can like just go through these videos on your own, and then you can actually sense whether we have completed certain chapters. Okay, I think we should be, if we want to take a look at AMAth next time, right? It should be further coordinate geometry, which is chapter 6.
Because I feel like for polynomial there's one
Binomial, yes.
I think there's a cubic thing
Cubic,
and you open it up.
cubic
Cause they
under polynomial.
yeah that one I haven't
So that means you are talking about polynomial. That means this one, chapter 1.
yeah but I feel like I haven't done yet.
Can you show me the question then?
Like factorize the things.
Oh, factorize is not under binomial. Factorize is more is under polynomial.
Yeah, polynomial. I was saying polynomial.
So binomial definitely we have covered off. For polynomial, factorize. Wait, I thought long division. I answer you right just now.
Oh no, wait. Can I take a picture of the thing?
Which one? You mean this one?
No. On my exercise book.
Come, live. For cubic, I thought this is the answer. I mean, this is the question you asked. Because this is also cubic, like you look at it.
And then the one I was talking is like factorizing it.
By the way, this is also factorized if you look at it. So basically, you're this cubic, right? You already have one factor, right? And then this quotient will be this quotient, let's say is this. So what you need to do, you need to factorize this, factorize this quadratic equation. So let's say you can factorize into this. This is factorized, okay? That's how you factorize the cubic. So did I answer your question?
Yeah.
So yeah. So we have learned, right? Okay. So did I answer your question? Yep. I think I have answered your question. And by the way, right, the one you show me, right? Actually, the one you show me, you are actually should be using the formula. Okay, you should be using a formula. There is a formula for cubic. That one you need to memorize. Okay, for this one you need to memorize.
Okay. But they never say what's the formula.
Hold on.
Very sure the working.
There is no. So don't you realize this is very similar to this one? Don't you realize? Don't you realize?
Yeah.
Okay. So that means there is a formula for these two also. Okay. So what you need to do, just Google cubic formula R. Or I can send you next lesson. I send you. Basically, you use formula. Okay. And I thought you should remember this one also. So that means these two looks very similar to this. Okay. Can. Okay lah. So yeah. So I will give you the formula. But I think you should have this formula somewhere in your math materials.
Oh, I don't have.
Oh, okay. Then never mind. Then I'll give you in the next lesson.
Okay.
Okay. Okay. So thank you for your time. So see you.
Okay, thank you.
Bye bye.
Bye.